Hello everyone, today's video I'm going to explain the second topic from the practice quiz 12, pH of a strong diprotic acid. Okay, so for this particular question, now let's take a look. Okay, so pH of a 0.34 molar solution of sulfuric acid. Okay, and then you go, oh, okay, so for pH of a diprotic acid, do I need to worry about other acids? Do I have other situations? The answer is no. There's only one situation for strong diprotic acid. This is as H2SO4. That's it. Okay, so no other options. Again, if you still remember your six strong acids, you also realize this is the case, right? So there's no other strong diprotic acid. Okay, so now that's again then reminds you, right? If you during the exam or a quiz you see H2SO4, you go, okay, so this is the case. I need to take the following steps. Okay, and then we're gonna actually work on this. Okay, so for H2SO4. Okay, so if you are asked to calculate the pH of sulfuric acid, and then this is what you really need to understand, therefore you can do the calculation. Okay, so for H2SO4. So what's so unique about it? Okay, so the thing is for H2SO4 there are two protons, right? You can donate or you can donate the proton one at a time. Okay, so take steps. Okay, so then therefore the first proton you can donate 100%. Okay, because it's a strong acid. Okay, so then you're gonna produce HSO4 minus. Okay, and hydronium ion. Okay, so that's the first step. Okay, and then please pay attention over here, right? It's gonna be 100% ionized into two those ions. Okay, and then the question is, right? So we still have another proton we can donate, and then therefore there is this following step. Okay, so the following step is they have HSO4 minus. Okay, gonna donate another proton. Okay, and then for the second step, it's not gonna be 100% ionized. It's gonna only partially. Why? Because HSO4 minus is weak. Okay, so it's a weak acid. Okay, so that's what's going on. Okay, so then you're gonna produce sulfate ion and hydronium ion. Okay, so this is the two equations involved. Okay, so that of course then you have a Ka value for this, and then that's why let's look at the question one more time, and that's also the reason why we see we're given with a Ka value for HSO4 minus. Okay, and then because we need it, right? We need for the second step. Okay, so now that's actually now do the calculation. Okay, so if we understand all this background info, okay, so then we're given where the concentration of sulfuric acid itself is 0.034, right? Okay, so that's 0.304, and then all of this will be generating or excuse me, or producing the same amount of HSO4 minus and same amount of hydronium ion from the first step, right? Okay, so then you go, why? Because it's 1 to 1 to 1 to 1 ratio, right? Okay, so it's like, excuse me. Okay, so if, right, it's like, right, when you use 1 mole of sulfuric acid, you produce 1 mole of the HSO4 minus and 1 mole of hydronium ion. Okay, but now you have 0.034, and of course, then you get the same amount. Okay, so that's for the first step. Okay, so now after the first step, you don't have any sulfuric acid, right? Okay, you're generating this too. Okay, so that's what I have, but that's not the end, right? So this H2SO4 is going to continuously having the following equation. Okay, so then therefore you go, oh, and this is weak acid, and now I have to set up ice table, right? So that's what this is about. Okay, so I'm going to set up the ice table. Okay, so water, we always don't need to worry. Okay, so ice table, and then this number, right? This number, right, will go into the ice table. Okay, so it's over here. Okay, now we have that, and then let's see, do we have any of sulfate ion from the previous step? Let's look at it. No, we didn't generate this. So at this moment, right? It's 0 because direction didn't happen yet for this second step. But let's look at hydronium ion. Okay, for hydronium ion, do we have some hydronium ion before this weak acid start to ionize? Yes, we do, because from the very first step, right, from sulfuric acid, we were generating 0.034 molar of hydronium ion. Okay, so that's why this is so important over here. Okay, so if you miss that, and of course, it's not gonna everything will be going the wrong direction from this point. Okay, and then we always like to calculate Q, then we know which direction it goes, and then once you know one of the product is 0, right? So then that means products over reactants that Q will equals to 0. Okay, so then Q is smaller than K. K is given from the question is 0.012, or you can express it as 1.2, or right, or you can express it as 1.2 times 10 to the negative 2. It's the same number. Okay, so that's for that. Okay, and then right, then we're gonna go. We know Q is smaller than K, so then we have negative here, positive and positive. Okay, so now we just fill out the S table. This is we are definitely very familiar with this process. Okay. Okay, so after this point, okay, we have the numbers for equilibrium. Okay, so now we will express equilibrium. Okay, so Ka, okay, Ka will equals to products over reactants. Okay, so the products will be, right, will be X times 0.034 plus X over 0.034 minus X equals the Ka value. Okay, so we get to this point, you go, now what should we do? Now what should we do? You go, oh, can I use small approximation? You go, looks complicated. Can I use small approximation? Then we'll go, no. The reason for that is that this this Ka value is too big to use small approximation. Okay, so now we know, okay, so we have to actually solve this, right? Solve this by using quadratic equation. Okay, so now we just need to, right, carefully carry out the the quadratic equation. Okay, so therefore we're gonna do the ones on top just stay as it is. I'm gonna do a cross multiply. Okay, so that's what we have, and now we'll just carry out this calculation. So on the left side, I have 0.034x plus x squared. On the right side, basically I'm doing this distribution, right? Okay, so earlier this is what I did, right? Okay, and then on the right side, I have 0.012 times 0.034 minus 0.012x. Okay, so now I'm just gonna put all of this on one side will make it equal to 0, so I can get to the generic expression, right? Ax squared plus bx plus c equals to 0. Then I can use quadratic equation. Okay, so now I'll just keep on working my equation, x squared. Okay, and then I move this to the left side, and then becomes positive, right? This becomes positive, so then I have positive 0.034 x plus 0.012x. Okay, and then I have this 2 multiplied and moved to the left side, and I had to add a negative sign. Okay, so that's what I have equals to 0. Okay, so now I'm going to put these two together. Okay, so I'm going to put those two together. Okay, so add them up. So now I have x squared plus 0.046x minus 0.00041 equals to 0. Okay, so I just did the multiplication over here. Okay, so now I have my generic equation, and then from here I know, right, my A equals to 1, my B equals to 0.046, C equals to negative 0.00, 0.041. Okay, so those are the ABC values. And now I know, okay, I use my quadratic equation, which would be x equals to 2a minus 4b plus minus b squared minus 4ac, right? Okay, so now I just plug the values in and get two solutions, right? One x actually equals to 0.05361 negative, okay? And the other x equals to 0.00761, okay? So that's the second x value we have, okay? And then from this point, okay, so then you go, oh, now what? Okay, so I have two solutions. Do I get two answers? Okay, so in mathematically, those two values are valid. Okay, however, for this chemistry question, if you look at the x, right, x represents the concentration of sulfuric acid. I'm sorry, the represents the concentration of sulfate ion. Okay, can that x be a negative value? We don't think so, right? Because concentration cannot be a negative value. Okay, so therefore, we know we only have one valid solution, which will be 0.00761. Okay, so now you go, oh, now I just need to take negative log. Okay, wait a minute, let's see what this x is, right? So the x we solved, but if we wanted to calculate pH, what do we need? We need hydrogen amount, and then which means you need to add 0.034 and x together, then that's the hydrogen amount concentration. Okay, so for hydrogen amount concentration is actually 0.034 plus this x value we just solved. Okay, so then you add these two up, you get 0.0416. Okay, so that's the concentration. Now it's easier. pH equals to negative log of hydrogen amount concentration. Then you'll get negative log of 0.0416. Then your pH is 1.38. Okay, so this is the whole process of the calculation. Okay, so as I want to say for this question, right? So definitely you need to understand these two, right, equations, and then you need to be able to fill out the S table correctly. Okay, then you solve it, and of course the solving process involve quadratic. Okay, so definitely for sulfuric acid calculation, you know this is the only question requires you, because I promised you, right? So this is requires you use quadratic. Okay, so then you'll be able to solve two solutions, and then you're gonna remember this is just x, right? You needed to add the original concentration of sulfuric acid, then that's what's going to give you the concentration of hydrogen amount, and then you'll be able to calculate the concentration, then do the pH. Okay, so this is a solving process for this question, and hopefully this is helpful, and then thank you for listening.